Course 3, Lesson 77. We are working with our inequalities, but now we are looking at some negative coefficients and how to deal with those. So, when we look at our inequalities, when we're working with these negatives, when we just have equations, we don't think twice about it, but when we have inequalities with negative numbers, when we are multiplying or dividing by a negative, we must flip the sign. So for instance, with this first inequality here, in order to solve for x, we would divide by -2. Remember, when we're working with these inequalities, we always want to solve for x. So we would say x, we would say -4. Now, it's natural to want to just leave it as a less than sign, but with inequalities, when we're multiplying or dividing by a negative, we have to flip the sign. So we actually have x is greater than -4. Now, the reason behind this, a quick short example of this is, let's say I have a true statement like 2 is less than 5. And I want to multiply each of these sides by -2, let's say. Now, we would assume, because of our normal thoughts about working with our equations, anything I do to one side, I can do to the other side without changing the truth statement. But in this case, when we multiply or divide by a negative number, we get -4 on the left, -10 on the right, and that less than sign in the middle is no longer true. So we need to make sure that we keep a true statement and flip it so that we have a greater than sign. So when we're just looking at normal numbers, this is how they work. Inequalities are not like our equations where we're allowed to do anything to one side and the other side without worrying about if we're changing the statement. Inequalities, we have to think about it a little bit more. So just to reiterate, if we have A is greater than B, these are some of our properties that we have. We can add a certain amount to each side. That won't change this truth statement. We can subtract something from each side. That won't change the truth statement. We can multiply by something if it's a positive number, or divide by something if it's a positive number and not 0, without changing the truth statement. But if we multiply or divide by that negative number, we have to flip the sign. Okay? So let's simplify some of these inequalities. Remember, we're solving them just like we would our equations, just remembering that with those negatives, we need to be careful. So in this case, to solve for x, I first need to undo the addition, or the addition subtraction. So I use addition to change this, to add 10 to each side. We don't need to flip the sign now because that's just adding. So we have a -3x is greater than 18. And now we divide by a -3. And we get x. And we get -6. And we flip the sign to be a less than sign. So that if we were to graph this, okay, on a number line -6, -5, and -7, we would have an open dot going to the left. Open dot always represents those less than or greater than. Closed dot is less than or equal to, greater than or equal to. All right. Let's look at this one as well. We're going to add 6 to each side and get -5x is less. Let's see, add 6, there we go. And we have is less than 5. We divide by a -5. And we get x is greater than -1. So on a number line, we would say, all right, we have -1, we have 0, we have -2. We have an open dot going to the right, showing those numbers that are greater than -1. So is -6 a solution to this inequality? And we would say no. One, because the graph, it is not pointing towards -6. So it's not in our solution set, and we can also plug in -6 into our inequality and see if it's true. So for example, we could do -5 times -6 minus 6, is that less than -1? That is the question. So we say 30 minus 6, is that less than -1? 24, is that less than -1? No, so it is not a solution to the inequality. I'm just going to show a couple more examples here. Now, on these type of problems, remember, we should probably expand first. There are other options, but for right now, let's just expand. And we get a -5x and a +15 is greater than 5x and -15. So in this case, I'm going to move all of my variables to that left side. That's where I want them anyways. So I'm going to subtract 5x from each side and get a negative 10x plus 15 is greater than negative 15. I'm going to subtract 15 from each side and get negative 10x is greater than negative 30. And I'm going to divide by negative 10. So x is less than, remember, flip the sign, 3. Okay, now graph, when you do this, we're going to have it on our number line. Remember, show me a few of your numbers. Open dot going to the left, going less than. All right, just a couple more examples here, and then we'll finish this lesson. Remember, always expand here, and we get negative 5x plus 25 is greater than 5x minus 25. I'm going to get my variables to the left side by subtracting 5x, and we get negative 10x plus 25 is greater than negative 25. Subtract 25 from each side and we get negative 10x is greater than negative 50. So x must be less than 5. Okay, so we have all of those numbers, open dot to the left, that are less than 5. All right, you can try this next one on your own. Remember, if we have a less than or equal to, it's going to be closed dot. But remember, get your variables to the left side. If you need to multiply or divide by a negative number, flip the sign. Okay, same with this one. Expand that negative sign, so we have negative x and a positive 7, and move them to the left side. All right, last example here. Marcy sees a shirt she likes that costs $50. She won't buy it unless it's $30 or less. To find the percent decrease in the price required, she solves the inequality. $50 minus 5 times the certain amount of decrease, it needs to be less than or equal to 30. So solve the inequality to find the maximum discount Marcy requires. So in this case, we have 50 minus 5x is less than or equal to 30. So we subtract 50 from each side and get negative 5x is less than or equal to negative 20. And we divide by a negative 5 to get x is greater than or equal to 4. Okay, what this is saying is that we need that maximum discount, all right, to be greater than or equal to 4. All right, well, I hope this is helpful for your homework and for studying.